this podcast, you'll find interviews with high-performing, successful individuals in life sciences. On a weekly basis, we cover their proven methods, principles, strategies, and mindsets to implement new technologies that scale to meet the needs of people in our world.
Today, I'd like to welcome to the podcast Dr. Jeff Andrews. Dr. Andrews is the Worldwide Medical Director for Women's Health and Cancer at BD Life Sciences. A board-certified obstetrician and gynecologist, Dr. Andrews has provided care in community settings in both metropolitan Toronto, Ontario, Canada, and Washington, D.C. He's also provided care in academic settings as an associate professor at Duke University Medical Center and at Vanderbilt University Medical Center. At BD, Dr. Andrews focuses on molecular diagnostics and the prevention of cervical cancer through early detection of cancer precursors on novel approaches to the diagnosis of infectious diseases in women. In 2020, Dr. Andrews has been working with the BD teams delivering SARS-CoV-2 diagnostics to meet the needs of molecular testing and for rapid point-of-care testing. Welcome, Jeff.
Thank you. It's good to be here, Don.
Yeah, so I heard that you're doing awful lot of great work around COVID and COVID testing, and I just would like to spend a little bit of time around what have you been up to and what is BD doing with regards to COVID testing?
So Veritor is a point-of-care platform instrument, if you will, that can read lateral flow cassettes, and the new test, the SARS-CoV-2 test, is for a protein. So antigen refers to a protein manufactured by the active live virus. And that protein is present whenever the viral load is above a threshold, probably about 10 to the fifth copies per mil. And that's happening just before symptom onset and about 7 days after symptom onset. And we also see evidence accumulating over the last several months that asymptomatic infected individuals have a viral load profile similar to symptomatic. The advantages of the Veritor or any antigen test is that you get a result in the order of 15 to 30 minutes, and it's point of care, and it's typically much less expensive than the PCR test, which is the original molecular test. And also by introducing these antigen tests in large numbers, it's alleviated some of the pressure on the PCR testing, allowing that to speed up a bit, which is important.
So I guess the one quick question that I would have from a patient perspective is, so is this one of those tests where they have to take the swab and take it all the way back to the back of your throat?
No, that type of swab would work on the test, but it's not necessary. The BD test works from what's called a nasal swab, which is just 1 centimeter inside the nose and not at all uncomfortable.
Oh, okay. All right. The specificity and sensitivity of the BD test. So tell me about that. So if I get the test, what are the chances that it's accurate?
So the sensitivity, meaning detection of someone who actually has the infection, is around 90%. And the specificity, meaning how correctly it identifies those who are negative for infection, is 99%. And we can talk a lot about what that means in practical use.
Yeah. So tell me a little bit about what does that mean? So if I go get the test, what does it mean?
So someone who's symptomatic that has some of the cardinal symptoms of COVID, which are fever, shortness of breath, and cough, or some of the other less typical symptoms, has a particular pretest probability of having COVID. And I think at this point, most of the clinicians are able to guess the likelihood that this person has COVID. But typically in symptomatic patients, you're looking at about 30% or higher pretest probability. So in that setting, if an antigen test is negative, there's a chance that you've missed the disease by having a false negative result. So whenever there's patients in a hospital or other setting where the risk is above 30%, the result of any of the FDA-approved antigen tests is considered presumptive when negative. And those people are advised that they're negative, but then reflex to a PCR test. On the other side of the equation, you have testing in asymptomatic people. Maybe they were exposed to someone, maybe they're living or working in a nursing home, that sort of thing. They have a much lower risk, well below 5%, probably below the positivity rate in their community, because people in those situations are usually being extra careful. So in that setting, there's no real statistical concern about false negative. However, if you're testing 1,000 people, you're going to have a few false positives in there, even though it's 99% specific. So sometimes when the number of positives is very low, it may be worthwhile reflexively testing the positives to identify a false positive. One of the most famous cases was Governor DeWine of Ohio, who was supposed to be with the president at some location, and he tested positive on a rapid test and then subsequently had 2 PCR tests that were both negative. So that was determined to have been a false positive. And of course, he was asymptomatic at the time and had been careful.
Good. And so what other sort of things does the BD Veritor test for?
It's in a lot of use for influenza A and B, known as the flu, testing throughout the year, throughout the world, but it's coming up on flu season here in the US. So that test is also available on the same platform as is the SARS-CoV-2 test. But the Veritor can also be used for strep, and there's other tests in development for that platform, because now that the platform's in wide use, it's obviously helpful to get more tests.
Excellent. And how long has your COVID test been available?
Since May.
All right. Very good. All right. The other thing that I'd really like to spend a little bit of time on is looking at your background and looking at all the stuff that you've done in women's health and cancer. So tell me a little bit with regards to what are you working on at BD that the listeners might be interested in?
So BD has a unique test for HPV, that's human papillomavirus, which causes a number of cancers, especially cervical cancer, but also causes most anal cancer, vulvar cancer, and about 60% of oropharyngeal cancer. It also causes something called venereal warts. There's a vaccine for that virus, which is in widespread use throughout the world. And eventually it may be possible to get rid of this virus, but in the meantime, it's causing cervical cancer. So the BD HPV test called OnClarity, it targets the actual genes that are called oncogenes that cause the cancer-changing events within our cells. And it also reports the different genotypes. So this HPV has about 1,000 genotypes, and 13 or 14 of them have been identified as causing cervical cancer. We can report those out. They are not all the same. So some have much higher risk, like HPV 16 is by far the highest risk, and others have lower risks. So if you know the genotype, you're able to stratify the risk somewhat. It gets even better if you can track it over time and know whether it's persistent or not, then you can really stratify risk. So at the time I joined BD, we were about to get the FDA approval for the test overall, but not this extended genotyping, because that required some type of clinical guideline so that the clinicians would know what to do with the results. And that clinical guideline was developed and released in April. And we got the FDA approval for what's called extended genotyping, reporting all those genotypes in July. So we're now going through some changes in the US to bring about additional ways of triaging or stratifying initial results. Over this last decade, the world has been switching from the Pap test, which is looking at cells on a slide, to HPV as the primary test for screening for cervical cancer. And then if the HPV test is positive, we still do the Pap test. We still look at those cells to figure out whether there's a lesion there. And so BD's development has been on the extended genotyping, and also we've been looking at self-sampling means that a woman could use a swab inserted in the vagina. It doesn't have to contact the cervix. And the HPV is also in that location. So we can use the HPV test to check the self-sample. This is useful because the majority of women will be negative for HPV, probably 90%. So that's all they need to do. It avoids an unnecessary doctor visit, unnecessary speculum exam. Those women who are positive could either come in to have a cervical sample, or there's some things you can do with the molecular testing, including this genotyping, to identify which women need to come in right away and which women could wait and be retested to see if it cleared, that sort of thing.
Very good. What platform does it run on? Which machine?
It runs on the Viper LT machine, and it also runs on our new high throughput machine, which is called the Core, COR. So the Core is launched in Europe and coming soon in the United States.
Excellent. All right. Very good. And I would imagine that given the platforms of those tests, that they're, from the time of sample collection to result is relatively quick.
Yes, it is. Just a few hours to run those tests. Now, if the HPV is positive, you still have to make a slide. And we do have some technology for artificial intelligence reading of slides, which is another project I've been working on. But assuming a human is reading the slide, then that's the rate limiting step in terms of how backlogged they are and when they get that slide read. But the HPV result will be ready same day, maybe reported the next day, and then the cytology to follow.
I like to ask the same three questions of everybody as well. So first of all, in terms of things that inspire you, give us an example of something that inspires you.
Well, on the subjects we've been talking about, I'm inspired by the fact that we can eliminate cervical cancer and these other cervical cancers if I should live long enough, potentially within my lifetime. So it's not some far off dream. And this is a goal established by the WHO. And so I'm very excited to be working on the elimination of those cancers. Paradoxically, it means we would no longer need the tests we just talked about, because we wouldn't have to screen for a disease that no longer exists. But how great would that be? And then secondly, I've, of course, like everybody else, been inspired by the pandemic that we're under and the terrible impacts it's having, not only the deaths, but the long-term illnesses that we're coming to understand. And particularly in nursing homes, because my own parents were living in a nursing home at the onset of this disease. And so we've been able to participate with the US government in providing programs and diagnostics for nursing homes. And obviously that's where a lot of the deaths have occurred. And in the absence of the relatives being able to be with them for all the PPE reasons. So it's very inspirational to be trying to fight against this pandemic, which we have to get rid of, and to be playing such an important role.
Thank you for that. What inspires you?
I love challenges, especially complex ones that involve working out a strategy. I just love hearing that there's some challenge that needs to be resolved and then coming up with solutions. And of course, I don't do that by myself, but by contributing a couple of ideas, other people start adding in their ideas. And as a team, you come up with something that's effective.
And what concerns you?
I'm concerned about the lack of appreciation of science in the US culture, which is across the board, really, whether it's about climate or genetics or infectious disease or cancer. And I don't think that scientists are given enough credit within our society. And I wish we spent more money on some of the important research areas, because we could really have breakthroughs if we invested more. And it's very hard for people who are scientifically trained to explain effectively why science is such a great thing, because it tends to get us all tripped up over ourselves. Whereas for science critics, it's pretty easy to put out anti-science information that sounds appealing.
Yeah. Yeah. So it is interesting. One of our previous episodes that should have come out through the night last night with Mona Jha, very focused in on a company that she has called Sound Effects. And she's switched the paradigm a little bit, which is interesting to me, that by changing the paradigm from creating a cancer test to actually funding the next round of research, she really is changing that thought around science.
Part of what I've been doing with COVID is explaining stuff. They said that, I think it was Bill Clinton was the head explainer. So as a clinician working individually with patients, you have to figure out a way to communicate ideas to people at a level where they're comprehending it and making sure they understand. And so I've been explaining a lot of things about diagnostics and statistics over the last several months, and it's important to make it understandable. And it's great when you hear the aha from somebody who's been trying to understand why something's the way it is, and then they get it. So to me, that's part of science. And you can think of, I'm terrible with names, but there's been a couple scientists on TV with series who were able to explain physics and other things in a way that everyone got it. And we need more people like that are gifted communicators.
We do. Absolutely, we do. And so I just wanted to thank you, Jeff, for being on the show. Thanks a lot for coming on and explaining the great work that BD's doing. I've heard also that your team's a part of the COVID task force as well with the government here in the U.S. And just thanks a lot. I'm sure it added a lot of additional things that you had to do, but without it, we wouldn't have a good test and wouldn't have a way of quickly telling a result. Obviously, having more tests that do provide answers as well are absolutely critical right now in terms of just making sure that we can really treat people the way that they need to be treated, and also not be too concerned with people that don't currently have the disease. So thank you for all of your work, and thank the BD team for that.
Thank you, Don. It's been a pleasure being here. Appreciate it.
Thank you for listening to Life Science Success. For complete details about this podcast, including show notes, how to get in touch with guests, and more episodes, please visit www.lifesciencesuccess.com. If there's someone you'd like for us to invite to the show as a guest, please let me know by sending me a message at the podcast website. Please click subscribe on your favorite podcast app, share the podcast, or tell a friend about it, and last but not least, rate the podcast. Thank you again.